Okay, cool. So first thing I've got for you today is a little introductory video that I resourced online, and it's a really, really, really good explanation of what a measurement system analysis is. After that, I've got a little bit of a discussion for us all to take part in. So I'm going to give people some questions to answer, and then we'll have a little bit of a discussion about that. Then I'm going to take you through the MSA case study that I have done. Okay, so I'm going to hit the play button on the screen. If it doesn't start, hi Dwayne, I feel like I haven't seen you for ages. How you doing? Hi Mariam. Hi Corey. So I'm going to hit the introduction. If it doesn't play immediately for you, the video, please hit the red button in the middle. Sometimes it can be a bit special for some reason and just doesn't start playing for everyone. Start playing?
Six Sigma, we take a lot of measurements of our process. Cool. MSA, or Measurement Systems Analysis, helps to make sure those measurements are accurate. And that's what this video is all about. Now, before we get started, let me mention that if you're interested in a free white belt certification course, you can access one at sixsigmasociety.org.
Is that double speakering for everybody, or is that just me? Speaking for everyone, right, cool. I'm just going to, I will unmute you all in a second, but I'm just going to mute everybody to make sure it stops doing that. Okay, I will mute myself as well. Okay, fab. So I really like that video. I think it gives you a really nice basic explanation of what a measurement system analysis is. And actually, I've had a look at their white belt course. If you have time to do it, it's not that long. It's quite a good little course. It's good knowledge. So I wouldn't not recommend that you have a go at that if you would like to learn a little bit more about Six Sigma. So,
In the world of Lean
want to
Six
have a
Sigma,
little, pardon? Sorry, did someone talk to me then?
Oh no, that was a video.
Ah, okay, cool. Okay, so got a little bit of a discussion to have here. So I'm going to hand out some questions, give you a couple of minutes to go away and research. So I've got Adam, you're at the top of my list. You can take what is a measurement system analysis.
Okay.
And then Andrea and Andrew, I know you're probably nearly together. So the two of you can take together, why do we use MSA? Okay. Andy H, I want you to have a look at what do we mean by a confidence interval? And Dwayne, you can take that question as well. Have a look at what we mean by a confidence interval in relation to MSA. Corey and Nick, you guys can have a look at what does rule of tens mean? And then Mariam and Ed, if you both want to have a look at what could cause error in our measurement system, Everyone happy with that? Cool. So yep. I'm going to give you 7 minutes till 20 past. So if I could read time, that would help, wouldn't it? And then we'll feedback. Cool, we nearly ready, guys?
Yeah.
Yeah? Okay, so Adam, you still with us? We lost Adam. Okay. Andrea, Andrew, why do we use MSA? What's the purpose of it?
Just do it. No, come to me. It's a performance measuring system to analyze an effective MSA process can help assure that the data being collected is accurate and that the system of collecting the data is appropriate to the process. So, well, we were talking earlier, you're using a system to check that your system is working.
Yep, exactly that. Which sounds, it sounds simple when you say it, but it's not about the screws, if you think about it. It's about how you measure the screws. So it's taking it that step back. You've got to make sure how you're measuring them is correct before you can take the measurements as being correct.
Yeah.
Okay. So other Andy and Dwayne. So what is a confidence interval?
It's a range of values and indicates the uncertainty of the estimate, and we
Okay.
use it to show the likely range of values of our population mean.
Okay, yeah.
So a confidence interval for the mean is a way of estimating the true population mean. Instead of a single number for your mean, a confidence interval gives you a lower estimate and an upper estimate.
Yeah. Okay, Dwayne, anything to add?
I think a simpler version is just it's whatever you want to achieve. So you have the confidence in whatever. So if you say 95% is you're confident that's what you achieve and that's your mean, if you like. So it's what you're confident that you're gonna minimum that you're gonna achieve. Yeah.
Exactly that. And I like it in those simple terms as well. So for me, it's that you're saying, for example, we've got a decking screw, yeah? The decking screw, the minimum size it can be is this. The maximum size it can be is this. And I'm absolutely positive that when we measure that, 95% out of 100 are going to be correct. Yeah, nice simple terms. So all we're saying is, what do we think will be right or wrong? Yeah. Nice one. Okay, so Corey and Nick, I gave you guys rule of tens. So what do we mean by rule of tens?
It's basically saying that the resolution of your measurement system needs to be able to fit at least 10 times into your process variation.
Yeah.
And if your resolution isn't small enough, it's probably not very precise as well.
Yeah. Nick, anything to add?
No, that's pretty much it, isn't it?
Yeah. So basically, make sure that you're able to fit your specification 10 times. Yeah. And that you measure 10 parts, because otherwise you're not going to have your resolution of your data isn't going to be clear at the end. And I have to say, this is one of the mistakes I made when putting the case studies together. Yeah. My amount of data was too much, and the difference between my upper and lower spec limit was too much. And what I ended up with was unmanageable results. So one of the things about rule of 10 is really trying to teach you is keep it simple. Yeah, 10 parts, 10 times. Okay, and then repeat that across multiple operators. Okay, if you need to go up from that, you need to go up in tens. Don't do 13 parts, 14 parts. Yeah, stick to that rule of 10 across the board. So, Mariam?
Hiya.
Hiya, you're right, hun.
Yep.
So Ed's abandoned you, I'm afraid. So I'm going to join you on this one. You get me for this one. So what do you think could cause error to a management system?
I've got equipment, so not using
Yep.
the proper tools, and then the quality of the equipment as well. You could have defects.
Yep.
I've also got the person actually carrying it out. They
Yep.
might not be following the procedures. Or
Yep.
maybe
100%.
incompetent.
Yeah. Human error is the biggest issue or cause of error within a measurement system.
Yeah, and then I've got the environment.
Yep, fantastic. You've got absolutely everything there. So, you know, we've got human error, environment, equipment, ineffective equipment, process or method. And then the last one you could really have is poor quality material that you're doing it with. Cool. So if we go back to the first question, which was what is a measurement system analysis? And to put it in really basic terms, yeah, a measurement system analysis is used to identify and analyze the accuracy and precision of your measurement system. It's used to validate the measurement system and confirm that your data is reliable. Okay, it basically goes back to the fact that you can make a decision you can trust. Yeah. So within Six Sigma, it's mandatory. Okay. And within your endpoint assessment projects at the end, it's also going to be a mandatory element if you want to walk away with the distinction at the end. So that's why the additional training I wanted to provide you with today. So now I'm going to play you a fun little video of me and some people doing some measurements. This is going to be wild. I hope you're excited and ready for this. And then we're going to go through actually running the MSA. So the scope of our case study is that Weasley Screws have produced decking installation products. They have won a contract with a nationwide decking retailer and installer called EDEC to provide their decking screws. Okay. The retailer requires the decking screws to be 63 millimeters. So Weasley Screws have set up a measurement system to check the screws all fall within the lower and higher specification limits. So our lower tolerance limit is 63. Our higher tolerance limit is 63.5. So I've got a 48-second video on measuring here for you guys. This is wild, so enjoy. It's got some funky music and everything. You all hear the music? Oh, that's just to give you guys an idea, yeah, of measuring. So you can see this is exactly how the measurements were taken. Okay, so we took 10 of Weasley's screws and we measured them. 3 operators measured each screw 3 times and we measured 10 parts altogether. Okay, so I'm going to stop sharing my screen for a second because I've got to bring a spreadsheet up for you. So you just hold the line for 2 seconds. Let me switch locations. So can everyone see my spreadsheet? Yes? Sorry, you have to talk to me now because I now can't see you guys.
Yes.
Yes?
Yes.
Everyone can
Spot
see
on.
me? Nice one.
Yep.
Excellent. Cool. So what we're going to do now is we're going to run the measurement system analysis. So we've got our things, and there's 2 ways in which to lay out the data. Okay, so this is the first way. So here we've got each of the parts, and this is split into operator A, operator B, yeah, and then at the bottom you've got operator C. The other way to do it is you can actually lay it out in this fashion so that you have your readings running along and your part numbers at the top. So depending on which MSA template you decide to use, the templates I'm going to show you today are available on the resource channel. So you should be able to get them from there. So this one is the easiest of the two templates that are available to you to use. So remember, you're going to need this information shortly. So you've got your lower specification limit and your upper specification limit. And then the first thing we're going to do is we're just simply going to grab all of our data. Okay, so we now selected all the data and we're going to go into our measurement system analysis. And then what you guys will have is the option to run an analyzed gauge R&R crossed measurement system analysis. Sorry, just 1 second. Sorry, my Hoover started going off then. Apologies, it's 3:30. It does it every day. So we hit analyze gauge R&R. And then it's going to say, have you selected all your data? So we know that we've got all of our data in place. And then we're going to hit next. So the first thing we're going to bring over is our part, then our operator, and then our measurement. Okay. And then everything else should be set up. We're going to leave our confidence level at 95. Standard deviation, whenever you're doing Six Sigma, will always stay at 6. So never touch your standard deviation unless there are instructions in which to do so. And then we're going to hit OK. So that's immediately going to bring me up my table. Yeah. So within my table, there are 3 pieces of information that I am specifically looking for. Okay. So we've got here our total variation. So does everyone want to make a note that our total variation is 41.76%? Okay. Right down at the bottom here, we've then got our gauge R&R. So in case you don't know what gauge R&R means, a gauge R&R is repeatability and reproducibility. So our overall percentage for repeatability and reproducibility, okay, is 17.44. And that breaks down into these 2 figures here. So if I just go home. Okay. So as you can see, they're those 2 figures at the bottom added together. So our reproducibility is 6.53% and our repeatability is 10.91%. Okay. So total variation 41.76. And then we've got 17.44 for our repeatability and reproducibility. Okay. So if we were doing this properly, we would, of course, go through here and we will put all our details in at the top. So our process tolerant is 0.5. Our standard deviation is 6. We would call it Weasley's screws. We would put in the date of our study, who it was performed by. Okay, just to make it look professional, to make sure we've added in all of those areas. But the key information we're looking for, total variation, and then our repeatability and reproducibility. So I'm just going to go back to my presentation now. So hold for me for 1 second. Oh, it's just uploading. Might be a sec, or at least I hope so. It shouldn't be long. Oh, it's thinking about it. There we go. So let's have a look at our acceptance criteria. So can everyone see that? Yeah. So
Yep.
looking at the overall acceptance criteria we've got here. So we had our total variation. How much was our total variation?
You know what Mark put this on my bench?
Oh,
41.76.
You wanted
It
you to
was.
check out.
So
what
looking
I
at our
told.
acceptance criteria there, is that an acceptable variation?
Yeah.
No.
Well, I've put it down as minuscule. I've classified 1 mil as minuscule. I've defined it. Yeah.
So we're going with no there, guys?
Yep.
Yeah. Okay. So then we've got our tolerance. So what was our tolerance level for our repeatability and reproducibility?
17.44.
Okay. So is our tolerance level acceptable?
Brilliant.
Maybe.
Okay. So we've got a maybe there from Andy. So when we're looking at our gauge R&R, okay, we should be looking at our tolerance level being less than 30%, okay? Our reproducibility and our repeatability together should be less than 10%, okay? And it does tell you that on the template that I just showed you. I just didn't scroll down to it, so you didn't immediately get the answer to the question, because otherwise it literally tells you at the bottom. So going back to our 41.76, is that a reasonable tolerance level for our measurement system? No, it's not, is it? So looking at our repeatability and reproducibility, is that acceptable for our measurement system?
No.
No. So is our measurement system acceptable?
No.
And what could we do to improve that measurement system? What was wrong with the way that we did it? You saw the video. What could we do to improve that? How could we have a more reliable measurement system?
Use a different tool.
Thank you. Excellent. What would you use?
Caliper, for
Mhm,
example.
mhm. Exactly. Anyone else? So we could retrain our operators.
Maybe we can also number the screws, so number 1 is always number 1.
Exactly. Excellent. I'm glad you noted that. Nobody else had noted that yet, Andrea, that I hadn't numbered the screws. But yes, that is a very important part that I specifically left out of that video. Each one should be definable as number 1, number 2, number 3, number 4, number 5, to ensure that we're actually getting, but all we did in that video, if you saw, was move them to the back and the front of a queue. How do we know that the next person then didn't pick them up the other way round? Yeah. So we've got how we prepared the materials to be measured. We've got what we use to measure them, and we've got the training that we can give the operators to be able to do the task. So basically, really what we're saying with that measurement system is we're going back to the drawing board, yeah? Yeah? If you were a national company taking on a national contract, and that is how you were going to measure your product to ensure that it met the requirements of your customer, do we think that that would be the way to do it?
No.
No. Okay, cool. I'm glad that you're all with me on the no there for many reasons. So what I wanted to show you there is that actually measurement system analysis sounds really scary. Yeah. And you get a really big spreadsheet that gives you absolutely loads of results on it. Yeah. But really, there's only two things that matter. What is your tolerance? Is it repeatable or reproducible? Okay. That is the information you need to know to understand whether or not the measurement system you have used is accurate, and therefore you can make decisions based on that. Okay? So accuracy, precision, repeatability, reproducibility. That is what we are looking for. If I'm measuring it, yeah, I should have had the same training, the same equipment, the same time in which to do the task as if I had got Andy to also measure that item. Yeah. Cool. Well, I hope that made sense to everybody and demystified MSA a little bit, because that was really my aim of the game, was to make it as simple as humanly possible, because not everybody is working in a manufacturing environment. There are those of us out there who don't work in manufacturing, and therefore isn't something we would have done all day, every day, or even seen before in our job roles. And I felt the presentation we all saw on Duty 7 was very complicated, and it made it sound really, really difficult, when really all we need to do is we need to very simply run a gauge R&R like we have done here, and show our ability to do that within our portfolios of evidence and our endpoint assessment. So I'm going to be running more sessions on the 17th and on the 24th. So if you would like to come again, it will be the same content, but you are very welcome to do this as many times as you like until you get it inside of your brain. I know it took me a few times the first time round. So if you have any feedback, if there is anything that wasn't clear on the session, you all have my details. Please come back to me directly. Let me know if there's anything else you think I need to add in. You know, basically, I've done this session for you guys to make sure that you understand the requirements of what a measurement system analysis is, why we do it, and how to complete one for your endpoint assessment. Cool? Everyone happy with that?
Yes.
Thank you.
Yeah,
All
thanks,
right.
Beth. Really appreciate it.
My pleasure. If
Beth,
anybody wants any more, shout
Can you
me.
stay 5 more minutes,
I can, yes.
please? Thank you.
No worries. Cool. Well, that's me. If everyone else has got any questions, let me know. If not, I will see you all soon, I'm sure.
Yeah, thanks, Beth.
Thanks, Beth.
Thank you, Beth.
Right.
See you later.
Bye.
Bye.